Welcome to this video. This is the first video in a short series of videos which I'll be making covering some of the contents of Stanisław Leśniewski's work, which, in English, is titled On the Foundations of Mathematics. The original title in Polish was O Podstawach Matematyki. Before we get started, please remember to hit the subscribe button and give this video a like. Don't forget to hit the alerts button as well so you'll know whenever I upload a new video. If you have any suggestions for other videos, then please let me know in the comments section and I'll see what I can do. This video is only meant to give a rough idea of some of the contents of Lesniewski's On the Foundations of Mathematics. I will not be going into great detail, and I won't be subjecting Lesniewski's work to severe and in-depth criticism. I may touch on a few criticisms here and there, wherever I feel it's appropriate to do so, but mostly I'll be taking Lesniewski's work as it stands. In this first video, I'll give a brief outline of the contents of the introduction, but most of the video will be concerned with the contents of Chapter 1. This series of articles by Lesniewski appeared over a period of a couple of years in various journals. There's an introduction and 11 chapters, all of which were originally published in Polish. Provided that I'm somehow able to obtain copies of all of the articles of this series, then I hope to cover all of the chapters to some extent in a series of videos. All of the translations into English from Polish that I present in these videos are my own. I've made a very rough translation of much of, so far, the first few chapters of Lesniewski's On the Foundations of Mathematics. Sometimes I may show the translations of certain passages on the screen, but most of the time I'll simply talk about the contents of certain passages in a more approximate way and without necessarily going into too much detail. I may have to paraphrase Lesniewski in some cases where I wasn't able to find a translation into English which fully captures all of the nuance of Lesniewski's words in Polish. But nevertheless, even when I paraphrase, I aim to get the main ideas even if I don't get all of the nuance. As mentioned in previous videos, I'm not a professional translator and I don't claim fluency in the Polish language. There are some passages in this text which I've had great difficulty in translating, and so there is the possibility that I've not translated completely accurately in some cases. I would of course be very grateful to anyone who can correct any serious mistakes that I've made in translating. A digital copy of the parts of this work that are covered in this video is in the public domain and available to download. I'll include a link to the download in the description to this video. I'll just quickly highlight some of the main points of the introduction without going into too much detail. In the introduction, Lesniewski gives some background information and autobiographical details relating to the history of the development of the current work. I won't go into any detail with this, but Lesniewski references several works and their authors whose work has in some way or other inspired his own work. In particular, he mentions Gottlob Frege's Grundgesetze, Whitehead and Russell's Principia Mathematica, Ernst Zermelo, Leon Chwistek, Alfred Tarski, and Mordechai Weisberg. Lesniewski says that in the current work he will present three deductive theories which together form one of the possible foundations of the entire system of mathematical sciences. The three theories are protothetic, which corresponds to the calculus of equivalent statements, ontology, and finally mereology, which is a theory which Lesniewski presented in an imperfect form in his Podstawy ogólnej teorii mnogości. The chapters of On the Foundations of Mathematics, which Lesniewski published in Polish, it appears, from my first impressions, to only cover the mereology part. It seems that protothetic and ontology were covered in some articles published in German after the current series of articles was published. The first chapter, titled On Some Issues Relating to the Meaning of Logistic Theses, presents some criticisms of Principia Mathematica. It seems that, in the first few chapters, Lesniewski is trying to show that the current, that is, current in the 1920s and 1930s, systems for the foundations of mathematics, such as Principia Mathematica, are in some ways deficient or erroneous. He shows the ways in which he believes them to be in error and shows how his approach will, supposedly, rectify these issues, thereby justifying his own system. What the reader is likely to notice is that whereas Whitehead and Russell in Principia Mathematica seem to be more concerned with the symbolic formal manipulations, Lesniewski seems to be more concerned with the meanings of the various statements in Principia Mathematica. Lesniewski points out various ambiguities in the meanings of what Whitehead and Russell say. As a mathematician, I'm naturally more inclined to make observations on the formal manipulations of Principia Mathematica, and so, when reading Principia Mathematica, I may subconsciously pick up on a certain aspect of the formal manipulations which may seem unusual and deserves comment, but I won't necessarily make observations regarding meanings without conscious effort to do so. To a mathematician, many of Lesniewski's comments on what Whitehead and Russell mean may seem utterly banal and pointless, since they're not typically things that a mathematician is interested in. However, Lesniewski was from a more philosophical background, and so it stands to reason that he had more philosophical perspectives when reading Principia Mathematica. The first couple of pages of this chapter give some autobiographical details which describe Lesniewski's first encounter with symbolic logic and Russell's antinomies relating to the class of all classes, which are not elements of themselves, through a book by Jan Łukasiewicz on Aristotle's Principle of Contradiction. Lesniewski describes his first experiences of symbolic logic in quite a negative way, saying that he was discouraged by the unclear and ambiguous commentaries provided by the proponents of symbolic logic. He says that he couldn't grasp what was the actual meaning of the axioms and propositions of symbolic logic, and, in particular, he mentions the comments provided by Whitehead and Russell, clearly referring to their work Principia Mathematica, though not specifically mentioning Principia Mathematica. Lesniewski suggests that a reader of Whitehead and Russell, who carefully considers their comments and tries to apply them, will easily grasp the difficulties with which Lesniewski struggled for a number of years. On page 170, Lesniewski suggests that a reader of Principia Mathematica who wants to understand the meaning of the primitive proposition 1.3 may refer to certain comments made by Whitehead and Russell relating to expressions of certain kinds which seem relevant. Lesniewski initially focuses on the interpretation of the assertion sign. He quotes some passages in the original English which are found in Principia Mathematica and which relate to the interpretation of the assertion sign. Lesniewski gives two ways in which the comments of Whitehead and Russell regarding the assertion sign may be interpreted. The first is that the propositions asserted by the authors are those propositions which in the expression assertion sign.p follow immediately after the assertion sign and the dots. The second interpretation is that the whole expression assertion sign.p is a proposition asserted by the authors. For both interpretations, he provides examples of passages from Principia Mathematica which appear to support that particular interpretation. Lesniewski suggests that, based on the examples that he has given of the various comments made by the authors of Principia Mathematica, that the reader will not be able to clearly determine what meaning the authors wish to give to, say, the symbol which they call the assertion sign. If a reader of Principia Mathematica wants to figure out what the authors mean by the assertion symbol, or how to understand the symbol when interpreted in informal language, then the reader will not be able to figure out the former, and regarding the latter, it's indicated by the authors of Principia Mathematica that to understand the assertion symbol through use of the phrase "it is true that" implies a change of meaning. Is this change of meaning significant or not? All we're told is that the assertion sign may be read "it is true that," but then we're told also that, although philosophically, this is not exactly what it means. Lesniewski says that on the basis of the various comments that are offered by the authors of Principia Mathematica, the reader will be forced to come up with his own interpretations of what is meant by the assertion symbol, since there's insufficient information in Principia Mathematica to clearly indicate what is meant by the assertion sign. I can confirm that in Principia Mathematica, and here I'm referring to the first edition, there are what appear to be conflicting comments. In particular, the apparently conflicting comments that I've noticed are in relation to predicative functions. I've made a video on the axiom of reducibility presented in Principia Mathematica, in which I talk about predicative functions. What I say in this video is in many ways guesswork, and seems to make things work, but I've no idea whether what I say in this video is exactly how the notion of predicative function is supposed to be understood. So the process of improvisation of interpretations which Lesniewski speaks of is, in my opinion, a very real issue when it comes to a careful enough reading of Principia Mathematica, even for someone who's more mathematically than philosophically inclined such as myself. It suffices to say that I spent a number of weeks trying to form a coherent theory which was consistent with as much as possible of what is said in Principia Mathematica regarding predicative functions. My theory seems to be satisfactory, but I wouldn't necessarily say that it's correct. On page 172, Lesniewski suggests some questions which may be asked by a reader of Principia Mathematica with respect to the meanings of the assertion sign and the comments made by the authors. The questions are: 1. If some expression P is a proposition, then is the corresponding expression of the type assertion sign.P also a proposition? 2. If some expression P having a meaning is a proposition, then does the corresponding expression of the type assertion sign.P have the same meaning? And 3. What exactly do we have to consider as axioms and propositions of the system of Whitehead and Russell? Entire expressions of the form assertion sign.P, or merely the parts of those expressions following after the assertion sign and immediately following the dot? In particular, is axiom 1.3 the whole expression assertion sign Q implies P or Q, or merely the expression Q implies P or Q, which forms part of the preceding expression? These are just some examples of the kinds of questions that may naturally arise in the reader's mind while reading Principia Mathematica. Lesniewski then presents some examples of the kinds of improvised ideas which he alluded to on page 171 that a reader of Principia Mathematica might come up with in order to explain away what he reads. These ideas are just possibilities and are not necessarily to be taken as representing the only possibilities. The logic leading to each different idea will be some combination of the information which is available to the reader. If the reader accepts certain bits of information and rejects other bits, then he will be led to a particular interpretation. Therefore, the ideas are in many ways quite subjective. A. The assertion sign means, according to Whitehead and Russell, exactly the same as we assert that. That is, the expression assertion sign.p can be replaced with the expression we assert that p, without any change in the meaning. If p is a proposition, then assertion sign.p is also a proposition, but with a different meaning to p. According to this idea, we might take the primitive proposition 1.3 as being the whole of assertion sign Q implies P or Q, and can be understood as meaning the same thing as we assert that Q implies P or Q. B. The assertion sign means, according to Whitehead and Russell, exactly the same as that which follows is asserted. That is, the expression assertion sign.p can be replaced with the expression that which follows is asserted, p, without any change in meaning. If p is a proposition, then assertion sign.p is not a proposition, but is a collection of the three symbols assertion sign, dot, and p. Thus we might take as primitive proposition 1.3 the expression Q implies P or Q. C. If p is a proposition with a meaning, then the expression assertion sign.p is also a proposition with the same meaning as p. Thus, says Lesniewski, the authors of Principia Mathematica wish to use the assertion symbol to indicate those propositions which they themselves assert. In principle, this would be no different to simply using a different font to present propositions which are asserted by this or that person, but of course changing the font doesn't really change the meaning of the proposition. In this case, we take assertion sign Q implies P or Q as the primitive proposition 1.3. Lesniewski points out that, one way or the other, some of the information given to us by the authors regarding the interpretations of the assertion sign will have to be ignored. The information is inconsistent and it's difficult, in fact I think the appropriate word may be impossible, to reconcile all of the bits of information with each other to produce an interpretation which accords with all of the information. Lesniewski then suggests some criticisms which may be levelled against each of the possible interpretations just given. A possible criticism that Lesniewski gives for A is as shown on the screen. It seems then that we're in a situation where we have conflicting information coming from the authors, which leads to a series of possibly incompatible and yet plausible interpretations of the information. But due to the conflicting nature of the original information, none of these interpretations can be justified as the correct interpretation. Whichever interpretation we choose to go along with is open to legitimate criticism. These criticisms can be backed up using the original information. Before moving on, please remember to hit the subscribe button and give this video a like, and don't forget to hit the alerts button as well so you'll know whenever I upload a new video. The example from Principia Mathematica from page 24 of the Introduction to the Second Edition, which Lesniewski gives in relation to the criticism of idea B, is a bit unclear to me, although I get the rough idea of what he's getting at. He's saying that although the authors have introduced the assertion sign to make it clear which symbolic propositions they are asserting, they use the assertion sign in front of propositions which they do not at any point actually assert. From all of this, we can safely say that Lesniewski is less than impressed with how Whitehead and Russell deal with the meaning of the assertion sign. At this point we might feel that Lesniewski has made his point, but just on the off chance that someone manages to find a satisfactory way to explain the meaning of the assertion sign, and which is compatible with all of the comments and information in Principia Mathematica on the topic of the assertion sign, Lesniewski decides, at the risk of overkill, to go a step further and show that whether we solve the problem of the assertion sign or not, we still have a bunch of other problems that have to be dealt with before we can hope to say that we have a clear idea of the author's intentions. Lesniewski continues with the analysis of the primitive proposition 1.3 based on the comments made by Whitehead and Russell in Principia Mathematica. Definition 1.01 of Principia Mathematica reads as shown on the screen. In particular, we're told that whatever comes to the left of the sign of equality is defined to mean the same as whatever comes to the right of it. And so Leśniewski says, on the basis of this definition and this comment, we're to interpret the proposition Q implies P or R as meaning exactly the same as the proposition tilde Q or P or R. We wish now to interpret the proposition tilde Q, and we're told in Principia Mathematica that if P is any proposition, the proposition not P or P is false will be represented by tilde P. Therefore it seems we're to understand tilde P as meaning exactly the same as both not P and P is false. But Leśniewski has noticed a problem with this though. He claims that the proposition P is false can only be meaningful under the assumption that the subject P of the proposition P is false is used with a material supposition. So at this point, I'll need to have a bit of a digression to illustrate roughly what is meant by material supposition. Material supposition can be illustrated as follows. Suppose I have a dog called Rover. Then I might say Rover is a dog, which seems a fairly uncontroversial thing to say. But I might also say Rover starts and ends with an R. And here we see a significant difference. The subject of the first statement, Rover is a dog, is the dog that the word Rover is being used to refer to. In the second statement, what is being said is about the word Rover itself, since it would be a very unusual thing to say about a dog. That is, the subject of the second statement is the referring word rather than that which the word refers to. In the second statement, Rover is being used with a material supposition. Often the context will make it clear whether a word or symbol is being used with a material supposition or not. However, in some cases, it may not be quite so clear. Suppose I simply say, X is Y. How do I make it clear whether X is being used with a material supposition or not? Well, if I'm using X with a material supposition, then I may write X in inverted commas instead of simply X. And thus, X in inverted commas is Y will provide the confirmation that X is being used with a material supposition. But in X is Y, then X is not being used with a material supposition. Obviously, this doesn't normally happen in ordinary written language. Both Rover is a dog and Rover starts and ends with an R are legitimate written statements, but if I want to try to minimize the risk of confusion, then I may write Rover in inverted commas starts and ends with an R. Sometimes I may also want to use a symbol to refer to the name of my dog. For example, I may use the symbol the name of my dog or my dog's name. These symbols, which refer to Rover in inverted commas, that is, to the written word Rover, may be denoted generally with Rover in 2 pairs of inverted commas. Similarly, Rover with 3 pairs of inverted commas is a symbol that could be used to refer to the symbol Rover in 2 pairs of inverted commas, and so on. Therefore, if we suppose that P is a proposition, then this means that this symbol or the collection of symbols is a proposition. However, it may or may not be the case that the thing that P refers to is a proposition. Just because P in inverted commas is a proposition doesn't mean that what is represented by P in inverted commas is also a proposition. As an extreme example, consider the symbol grass is green. This written symbol is clearly a proposition. But suppose that I've named my dog Grass is Green. Then to say grass is green as a dog is not an absurd thing to say. In fact, it's true since grass is green refers to a dog with the name Grass is Green. On the other hand, grass is green in inverted commas is a dog is an absurd thing to say, as would grass is green as a proposition. It's also worth bearing in mind that only propositions can be true or false. Thus, if P is false is to be meaningful, then we must have that P, without inverted commas, is a proposition. Therefore, Whitehead and Russell say that tilde P means the same as P is false can only make sense if P is false, it's talking about the proposition P with inverted commas. Therefore, we must understand P is false as really meaning P in inverted commas is false. The subject of the proposition P in inverted commas is false is P in 2 pairs of inverted commas, which, as Lesniewski points out, is to be understood as not being used with a material supposition. P with 2 pairs of inverted commas is the symbol used to denote the proposition P in inverted commas, and so P with 2 pairs of inverted commas will not in general be a proposition. As I read the comments of this page, I was initially drawn to thinking about the similarities with the Gray's Elegy passage in Bertrand Russell's article on denoting. And thus we conclude that whenever we encounter the symbol, which may be written, spoken or whatever, tilde p, we're free to replace this symbol with either not p or p in inverted commas is false, without any change in meaning. Much of what Lesniewski is explaining on pages 176 onwards is speculative, in the sense that the assumptions that are being made are assumptions that may reasonably be made by a reader of Principia Mathematica if they are basing their interpretations on what Whitehead and Russell actually say. That's not to suggest that the reader of Principia Mathematica will make these assumptions, nor is Lesniewski claiming that this is how Principia Mathematica must be interpreted. Just that these particular assumptions, if made, are supported and justified by what Whitehead and Russell say. Lesniewski then goes on to show what are the consequences of this particular interpretation that he's outlined. Pages 176 to 179 are quite repetitive and laborious to get through. I will, however, go through quite carefully the contents of the few pages from page 176 onwards, where Lesniewski derives a series of propositions by making various substitutions suggested by the comments of Whitehead and Russell in Principia Mathematica. I'll show on the screen how each proposition is derived and indicate the relevant rule of substitution used. We see, for example, that from A, by replacing the symbol tilde q with not q, we obtain B. And similarly, by replacing the symbol tilde q of A with p in inverted commas is false, we obtain C. The quote from Principia Mathematica cited at the top of page 177 suggests that we're able to replace the symbol that represents the disjunction of p and q with either p or q, or with p in inverted commas is true or q in inverted commas is true. Note here that the quote from Principia Mathematica suggests that the disjunction of p and q means the same as p is true or q is true, but we must remember that we have to understand p is true and q is true as really meaning p in inverted commas is true and q in inverted commas is true, as explained earlier in the video. Thus from A we obtain, using the appropriate substitutions, D and E, as shown on the screen. Moreover, from propositions A, D and E, we obtain the propositions F, G and H, respectively. From proposition B, we obtain propositions I and K. From proposition C, we obtain propositions L and M. How the propositions N to X are obtained will be shown on the screen. Note that what Lesniewski is doing here is gradually reducing the symbolic representations to natural language interpretations. Thus the propositions P to X are all expressed in natural language. All logical symbols have been replaced with an appropriate natural language equivalence. Lesniewski says that if we consider the proposition Paris lies on the Seine implies Warsaw lies on the Seine or Warsaw lies on the Vistula, and produce a series of interpretations of this proposition, uppercase f to h and n to x, which correspond respectively in form to lowercase f to h and n to x, then the reader of Principia Mathematica has no reasonable way of considering the possible interpretations uppercase f to h and n to x as all being equivalent to one another, but can reasonably suppose that no proposition uppercase f to h or n to x is equivalent to any other. This latter supposition can be justified by noting that one of any pair of propositions from f to h and n to x makes a reference to some object that the other proposition of the pair does not. He looks in particular at propositions p, q and t. The translations of the relevant sections are shown on the screen, which go some way to explaining why we might suppose that the propositions f to h and n to x are not all equivalent. Lesniewski returns to the problem mentioned earlier about what to accept as axiom or primitive proposition 1.3. He notes various interpretations of P implies Q, suggested through comments by Whitehead and Russell, and gives a series of possible interpretations of the primitive proposition 1.3 using these comments of Whitehead and Russell, which are summarised in gamma to zeta. The derivations of these interpretations will be given on the screen along with the relevant rules of substitution used. He goes on to say that, again, there is no reasonable way to consider all of these propositions as having the same meaning. The reader puts in the effort to try to understand the meaning of the primitive proposition 1.3, but all of this effort leads to the chaotic mess of possible interpretations which have just been outlined in this chapter. Things would possibly be even worse if the reader of Principia Mathematica were to try to refer to any other comments made by Whitehead and Russell concerning the interpretation of any of these symbols, and which haven't been mentioned already by Lesniewski in this chapter. This example of the interpretation of primitive proposition 1.3 is given by Lesniewski to indicate the kind of issues with which Lesniewski struggled for a number of years in regard to symbolic logic. However, he suggests that, after much consideration, it seems to him that if the assertion symbol is disregarded, and that the symbols tilde P, the disjunction of P and P implies Q are consistently interpreted as not P, P or Q, and if P then Q respectively, and supplemented with brackets wherever necessary, then things start to add up, but that these symbols should not be interpreted by means of propositions relating to propositions and which assert a relation between propositions. Thus we have, for example, that Q implies P or Q is to be interpreted as if Q, then P or Q, and so on. And this brings us to the end of Chapter 1. Thank you for watching. If you found this video useful, then please hit the like button and subscribe to my channel. You can see more videos on various topics on my channel, and if you have any suggestions for topics for future videos, then please feel free to let me know, and I'll try my best to put something together. Don't forget to hit that subscribe button, and keep an eye out for new videos being uploaded to my channel.